Hello children, welcome all. Let's continue our chapter Combustion and Flame. Before we continue our chapter, let's have a quick recap of the chapter, whatever we have learned till now. We have learned what is combustion. Combustion is a chemical process in which a substance reacts with oxygen and generates heat in that process. And then we have learned about what are combustible substances. Combustible substances are those substances that undergo combustion, and the substances which undergo combustion give off heat and sometimes light. Light will be in the form of flame or glow when they react with oxygen. And then we have learned about non-combustible substances. Non-combustible substances are those substances that do not undergo combustion or burn. Then we have learnt about conditions necessary for the combustion to take place. What are the conditions necessary for the combustion? Combustion requires fuel. Combustion only take place when there is a fuel which produces heat and light when it catches fire. For example, petrol, diesel, etc. Then second condition is combustion requires heat. Then combustion requires air. So these three conditions are necessary for the combustion to take place. Then we have learned about matchstick, isn't it? And the matchstick contain antimony trisulfide and potassium chlorate. Then the matchbox, which has both two sides of rubbing surface. The rubbing surface of the matchbox has powdered glass and little red phosphorus. As we know that red phosphorus is less dangerous than white phosphorus. So nowadays the side of the matchbox contains powdered glass and little red phosphorus. Then how it works, when we strike the matchstick against the rubbing surface, some red phosphorus get converted into white phosphorus, and then this immediately reacts with potassium chlorate present in the matchstick head to produce enough heat to light to ignite antimony trisulfide and thus start the combustion. Thus the matchstick starts burning. Then we have learnt about different substances catch fire at different temperatures, isn't it? That is, the lowest temperature at which a substance catches fire is called its ignition temperature. So what is ignition temperature? The lowest temperature at which a substance catches fire is called its ignition temperature. Then we find that combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. The substances which have very low ignition temperature and can catch easily and can easily catch fire with flame are called inflammable substances. So what are inflammable substances? The substances which have very low ignition temperature so that it can easily catch fire with flame are called inflammable substances. Examples of inflammable substances are petrol, liquefied petroleum gas, kerosene, etc. Then how do we control fire? We can control fire by the following reason, one or more of the following reasons: by removing fuel, by cutting off the air supply, or that otherwise called as oxygen supply, cutting off heat, or lowering the temperature of fuel. By one or both all these three reasons we can control fire. Then we have learnt about when should we use or when should we not use water to extinguish fire. When should we use water to extinguish fire? When wood, paper and clothes are on fire, we can use water to extinguish them. What is the reason behind it? Water lowers the temperature of burning material below its ignition temperature and thus the fire stops burning. When should we not use water to extinguish the fire? We should not use water when electrical equipment is on fire, as water may conduct electricity and give shock to the people, those who dousing the fire. Also, we should not use water to extinguish when oil or petrol catches fire, because as water is lighter than oil, uh, uh, as oil is lighter than water and petrol, water sinks down. Oil and petrol keeps floating on the top and keep burning, because oil and petrol, as it is lighter than water, it floats on water, isn't it? That is, water sinks down. Oil and petrol keeps floating on the top and keep burning. And what should we do when electrical equipment or inflammable material catches fire? That is, we have to use extinguisher, fire extinguisher, where carbon dioxide is being released. Carbon dioxide is the best fire extinguisher in such cases. Carbon dioxide is heavier than oxygen, and hence it covers the burning materials like blanket and cuts off its oxygen supply. Also, it does not harm the electrical equipment. Carbon dioxide can be stored as liquid in cylinders at high pressure. When it is released, it immediately expands and cools down and covers the fire like a blanket, and also it brings down the temperature of the fuel. And we can also pour dry chemicals like sodium bicarbonate or potassium carbonate on the fire as they release carbon dioxide near a fire. So these are the different methods we can use to extinguish fire. Then now let's continue different types of combustion. Combustion, mainly there are three types of combustion: rapid combustion, spontaneous combustion, and explosion. So now let us learn one by all these three methods in a detailed manner. Rapid combustion, combustion in which a gas burns quickly, producing heat and light in this process. So combustion takes place very quickly. For example, gas which burns quickly, producing heat and light, is called as rapid combustion. Example, LPG, liquefied petroleum gas. That is what we use at our house, isn't it? The LPG cylinder, when you open and when you keep the burning mastic, immediately it catches fire. That is called as burns quickly, producing heat and light, is called rapid combustion. Spontaneous combustion, combustion which a material bursts into flame suddenly without applying heat. Got that? Suddenly it burst into flame without applying a heat. Example, phosphorus, which burns at room temperature. And spontaneous combustion of coal dust often causes accidental fire in coal mine. Coal mine, when they mine to take coal dust comes out, and which sometimes catches fire suddenly, which burst into flame without any heat applying it to it. This is called, because of which accidental fires cause. For children, heat from the sun or lighting may also cause spontaneous fire, forest fire. So these are spontaneous combustion. That is, spontaneous combustion means where the material bursts into flame suddenly without applying a heat. Example, phosphorus, which burns suddenly at room temperature. Coal dust while mining the coal in coal mines causes accidental fire. Heat from the sun and lightning also causes spontaneous forest fire. Now next, third method is explosion. That is when a material bursts suddenly to produce heat, light and sound. On the application of heat or pressure is called explosion. The difference between spontaneous combustion and explosion is, in spontaneous combustion, material bursts into flame without applying a heat. Or children, and in explosion, materials burst suddenly by applying heat or pressure, so that it produces heat, light and sound, is called as explosion. Example, crackers and fireworks. When we keep here applying heat, then only crackers burst, isn't it? So that is called as, and it produces large amount of heat, light and sound. So this is called as explosion. So we have learned three types of combustion: rapid combustion, spontaneous combustion and explosion. Now let's study about flame. Flame, what is flame? Flame is a hot glowing body of ignited gas which is produced when something is on fire. But that flame, when it is produced, flame, if you see, it is hot, glowing, isn't it? Of ignited gas, when gases get ignited, which is how the gas will be produced when something is on fire, it produces. Got that? So it is called as flame. You can see flames of kerosene lamp, candle and burner. See in the figure, you can see different flames which are produced by kerosene lamp, candle and burner, and even here, and also that gas stove, kitchen stove also produces flame. So children, it is nothing but a hot glowing body of ignited gas. And all materials, they don't burn with flame, isn't it? Some materials burn with flame and some do not burn with flame. Now let us, here you can see the table, material which burns while which forms flame while burning and which does not form flame while burning. Candle, if you see candle, it forms a flame while burning, isn't it? Then magnesium, when you keep burn magnesium ribbon, it burns brightly, isn't it? But it does not form a flame. Camphor, it forms a flame. Kerosene stove, it also forms a flame. Kerosene stove or the kitchen stove, which is used by using LPG cylinder, that also forms a flame. So some materials, they burn with a flame and some they do not form a flame while burning. So which material, which substances forms flame? The substances which vaporize during burning gives flames. Got that? Why some substances only they burn with flame? That is, the substances which vaporize, which evaporate during burning give flames. For example, kerosene oil and molten wax, that is candle, how it, through wick. Wick means what? That thread by which candle wick, we know, no, this by where we lit up this heat, that is wick, isn't it? So for the molten wax, molten means melted wax, it rises through the wax, through the wick and vaporized during burning and form flames. Charcoal or coal, on the other hand, they do not vaporize and so they do not produce flame. For children, so the substance which vaporize during burning, they give flames, and substances which do not vaporize, they do not form flame. Now let's see the activity to show that the vapors of wax coming out of the glass tube is the cause of flame produced. Now we have learned, isn't it, the substance which vaporize during burning form flames. Example, wax and kerosene oil. Now see here, you have to light a candle. You have to be very careful and then hold 4 to 5 centimeter long thin glass tube with a pair of tongs and introduce its one end on in the dark zone of a non-flickering candle, that is in the middle, not at the tip, but that in the one end of the dark zone of a non-flickering candle flame. Now bring a light. We have again, you have to first light a candle, then hold a 4 to 5 centimeter long thin glass tube. Glass tube in the sense, at the center you can see white hole will be there. Got that? Glass tube, and you have to hold the glass tube with a pair of tongs and introduce and keep one end of the glass tube on the flame of a candle. Now what we have to do is bring a lighted matchstick near the other end of the glass tube. Got children? One end of the glass tube is on the flame of the candle and now we have to keep a lighted matchstick on the near the other end of the glass tube. Now what we can see, we see a flame caught at the end of the glass tube after some time. The other end of the glass tube, if you keep a burning matchstick near the other end of the glass tube, we can see that flame caught. The other end also, we can see the flame after some time. What is the reason? What does it produces a flame at the other end of the glass tube? That is because when you keep the end of the glass tube at the end and the flame of the candle, the vapors of the wax coming out, and it passes through the glass tube and it reaches the other end of the glass tube also. That vapor, it catches fire. When we keep the burning matchstick at the other end of the glass tube, it catches fire and it causes the flame to be produced. Got children? So till now we have learnt about the substances which burn in air are called combustible substances, and then we have learnt oxygen is essential for combustion, and during the process of combustion heat and light are given out, and combustible substances are those substances that undergo combustion. That is the substances it gives off heat and light. A light will be in the form of flame or glow when they react with oxygen. And non-combustible substances are those substances that do not undergo combustion or burn. Then we have learnt about how do fire extinguisher work. Fire extinguishers are devices used to put off fire. They either cut off the air supply to the fire, or they cool off the fuel below its ignition temperature, or they do both. That is, they cut off the air supply as well as cool down the temperature of the fuel. And then we have how learned about how do we control fire. We can control fire by one or more of the following. That is by removing the fuel, by cutting off the air supply, that is nothing but oxygen supply, by cutting off heat or lowering the temperature of the fuel. Then we have learnt about types of combustion: rapid combustion, spontaneous combustion, and explosion. Then we have learnt about flame. Flame is nothing but a hot glowing body of ignited gas which is produced when something is on fire. Then the substances which vaporize during burning, they give flames. Example, kerosene oil, molten wax, etc. Which the molten wax rise through the wick. Even kerosene oil lamp we use, isn't it? The kerosene oil also, it rises through the wick and are vaporized during burning, and thus it forms flames. Charcoal, on the other hand, does not vaporize and so does not produce flame. So that's all for this session, and we'll see soon in next session about, we are going to learn about structure of flame. Thank you.